Kurt Gödel entered the world on April 28, 1906 in Brunn, Moravia, at the multilingual, multi-confessional fringe of the Habsburg Empire. The factory that employed his father imported raw wool from Britain and exported finished yarn across the monarchy. Dinner table talk ranged from tariff schedules to Goethe quotations, giving the younger of the family's two sons a sense that the material and the ideal belonged to one seamless reality. From infancy, he peppered relatives with interrogatives so relentless that they christened him Herworum, Mr. Y, a nickname he would never really outgrow. Scarlet fever at age 6 left him with a weak heart and a fear of germs, planting the first seeds of the hypochondria that later consumed him. But it also confined him to bed long enough to master geography and prove rudimentary theorems from a Czech gymnasium text. In 1924, Gödel moved to Vienna to study physics, enchanted by Hermann Weyl's dream of unifying gravitation and electromagnetism. The new city, however, offered a different seduction. Carl Menger's private colloquium, where mathematicians dissected Hilbert's program and the nascent edifice of set theory. Gödel switched from physics to mathematics in a single semester and soon absorbed more logic than most lecturers knew how to teach. Hans Hahn guided him through Hilbert and Ackermann's Grundzüge der theoretischen Logik, while Moritz Schlick pushed him to read Kant and Frege in the original. Yet, Gödel never fully entered the positivist camp. The Vienna Circle's empiricism, with its suspicion of metaphysics, struck him as an unnecessary self-maiming of reason. At 21, he submitted a dissertation proving the completeness of first-order predicate calculus, that every logically valid formula is derivable from Hilbert's axioms. Completeness seemed to place a tidy capstone on Hilbert's blueprint, but Gödel had already perceived the fissure beneath it. Over the next 2 years, working alone in Café Reichsrat amid cigarette smoke and clinking coffee spoons, he perfected what is now called Gödel numbering, a method that encodes syntactic objects, symbols, formulas, proofs as natural numbers so that arithmetic can talk about the machinery of its own language. With this arithmetization in hand, he built a self-referential statement that asserts its own unprovability within the formal system. If the system is consistent, the sentence is true but unprovable. If the system proves the sentence, it collapses into inconsistency. Thus, in 1931, the incompleteness theorems demonstrated two shattering facts. No consistent, recursively axiomatizable theory strong enough to capture P&O arithmetic can be complete, and such a theory cannot, by its own lights, prove its consistency. Hilbert's dream of a finitary, mechanical foundation for all mathematics died in a 12-page paper quietly deposited with a Monatscheft for mathematik. The intellectual earthquake won Gödel an invitation to Königsberg's 1930 Congress, where von Neumann rushed to confirm the proof line by line, and to Princeton in 1933, where the Institute for Advanced Study had just been founded. Yet the accolades were offset by private storms. Political violence in Austria, culminating in Dollfuß's assassination, frightened the shy logician, and a misdiagnosed stomach ailment spiraled into depression. In 1934, he spent months in a sanatorium. 2 years later, he attempted suicide with sleeping powder. Only Adele Porkert, a spirited nightclub dancer 9 years his senior, could coax him back to work. Their marriage in September 1938 scandalized Gödel's bourgeois relatives, but gave the mathematician a companion who understood both his brilliance and his brittleness. March 1938 brought the Anschluss. Though ethnically German, Gödel harbored no sympathy for National Socialism, and his close friendship with Jewish colleagues made Vienna dangerous. In January 1940, he and Adele embarked on Odyssey: Vienna to Moscow by train, Vladivostok by Trans-Siberian, Yokohama by ship, San Francisco by Pacific liner, and finally across the United States to Princeton, where Gödel accepted a permanent IS post. Albert Einstein greeted him like a long-lost disciple. The two began almost daily walks. Einstein smoking cigars, Gödel sketching logical paradoxes in the air with a gloved hand. During the 1940s, Gödel produced a stream of landmarks. He defined the constructible universal, a cumulative hierarchy built only from sets definable using first-order formulas, and proved that Zermelo, Frankel's set theory, cannot refute the axiom of choice or the generalized continuum hypothesis, provided ZF itself is consistent. These relative consistency results inaugurated the era of independence proofs and changed the orientation of set theory from discovering axioms to measuring their strength. Meanwhile, he devised the dialectica interpretation, recasting intuitionistic arithmetic in a functional language that later inspired proof-theoretic ordinals and computer science-type systems. For diversion, he tackled general relativity and, in 1949, published a rotating cosmological model whose closed time-like curves permit travel to one's own past, implications that disturbed physicists but delighted philosophers. Citizenship hearings in December 1947 showcased Gödel's fusion of rigor and naivete. He had scrutinized the U.S. Constitution and detected a technical path by which a legally elected government could become an autocracy. When an examiner asked whether such a loophole existed, Gödel began sketching the argument in earnest, and only the hurried banter of Einstein and economist Oscar Morgenstern deflected the conversation into safer waters. Sworn in moments later, Gödel nonetheless retained a lifelong unease about political structures. The 1950s and 1960s saw fewer publications but deeper notebooks. Gödel drafted an ontological proof of God's existence in modal logic, extending Leibniz's fragmentary notes into a formal argument. He explored Gödel, McKinsey, Tarski correspondences between intuitionistic logic and S4 modal systems, and he planned a grand refutation of materialism via the mind-body problem, convinced that mathematical intuition revealed non-computable mental acts. Yet paranoia tightened its grip. He feared contamination in food, drafts from open windows, even invisible radiation from fluorescent bulbs. Adele's patient oversight kept him functioning, but after her 1977 hospitalization, he refused to eat anything not prepared by her. Weight charts in his diary fell like a descending sequence of ordinals: 90 pounds, 80 pounds, 75 pounds. On January 14th, 1978, he died of self-starvation, the death certificate citing malnutrition and inanition precipitated by personality disturbance. Gödel's Necklace, over 20,000 pages in Gabelsberger's shorthand and spidery current, remained sealed for years, but its gradual publication reveals a mind ranging freely across ontological arguments, Carnapian semantics, quantum foundations, and biological form. His incompleteness theorems ended an era of formalist optimism yet opened richer vistas. If mathematics transcends any mechanical schema, then creativity, not calculation, sits at its core. His constructible universe distilled a method, inner models, that continues to frame debates over large cardinals and determinacy. His dialectica interpretation links logic to computation, embodying ideas later realized in functional programming. Even his rotating universe influences discussions of cosmic chronology protection. Kurt Gödel, thus, stands with Euclid, Cantor, and Turing as a thinker who permanently altered what it means to reason. He proved that finitary methods cannot capture the infinitude they describe, that consistency itself lies beyond formal self-certification, and that mind, at its zenith, reaches into realms no algorithm can exhaust. Yet the same temperament that scaled those heights could not negotiate ordinary life. In Gödel, the human and the transhuman collided, a frail body haunted by germs and dictatorships, a towering intellect conversing with infinity. His story warns that the quest for absolute certainty exacts a toll measured not in QDs, but in sleepless nights and empty plates, even as it gifts humanity with insights that no darkness can efface.